This is Cambridge IGCSE for Paper 4 Chemistry, Theory Extended, May-June 2019. Question number 1. The names of 8 substances are given. Answer the following questions about these substances. Each substance may be used once, more than once, or not at all. State which substance is the main constituent of natural gas. That will actually be methane. B, a reactor in respiration, so cells actually respire oxygen. C, the main constituent of bauxite. Bauxite contains aluminium oxide. Let me just write down the name of it, aluminium oxide. And D, a product of photosynthesis. So plants actually produces oxygen for us to respire. So actually this is a repeated answer, which is oxygen. And a greenhouse gas, that will also be methane. And lastly, a macromolecular solid, that will be silicon oxide, which is commonly found in sand and quartz. Moving on to question number 2. Sodium 22, sodium 23, and sodium 24 are isotopes of sodium. Describe how these sodium isotopes are the same and how they are different in terms of the total number of protons, neutrons, and electrons in each. So as we can see, they have the same number of protons. And because they're neutral, so which means that their electrons should have 11 as well. So same electrons, and then they have different number of neutrons, right? Leading to their mass number being different. So moving on to the next question. Why do all 3 isotopes have an overall charge of 0? So that will be due to the number of protons are equal to number of electrons. Moving on to 3. Why do all 3 isotopes have the same chemical properties? So that will be due to the same reason as why the same group of elements have the similar chemical properties. It's due to these isotopes have the same number of electrons, specifically in the outer shell. All right, group 1 will tend to donate 1 electron, group 2 will tend to donate 2 electrons, so which makes them similar in terms of how they carry out their chemical reactions. Right, moving on to 4. Why do sodium ions have a charge of +1? So sodium ions are actually formed when sodium atoms donate 1 electron out, and the charge is due to there are one more proton than electrons. Right, moving on to the next question. Carbon is an element which exists in different forms. Name 2 forms of the element carbon that have giant covalent structures. So carbon is found as a macromolecule, a giant covalent structure in mainly 2 popular substances, which are diamond and graphite for IGCSE syllabus. Right, moving on to 2. Name the oxide of carbon that is a toxic gas. That will be carbon monoxide. Right, moving on to the next question. 3. The question is about phosphorus and compounds of phosphorus. Phosphorus has the formula P4. Some properties of P4 are shown. Name the type of bonding that exists between the atoms in the P4 molecule. So this, as we know that phosphorus is a nonmetal, and this is actually a molecular structure, meaning that this is actually covalent bonding. Right, moving on to 2. Explain in terms of attractive forces between particles why P4 has a low melting point. Not to be confused with the previous question, in a P4 molecule, the P atoms are joined together by covalent bonding, but between the particles, in which between the molecules, there's a very different attractive force that exists between the molecules. All right, and then the nature of, allow me to draw this molecule real quick. So imagine this is a P4 molecule with another P4 molecule. In between these two molecules, there's actually a very weak force of attraction. All right, so the reason is the forces of attraction between P4 molecules is weak, which means that it only needs a small number, or should I say the amount of energy to break. Let me rephrase this by changing this to amount, small amount of energy to break. All right, moving on to the next question. 3, explain why phosphorus is a non-conductor of electricity. In order for the substance to be able to conduct electricity, you should think of the agents that are able to conduct electricity. When a substance have charged particles that allows electricity to be conducted. But for phosphorus, within the molecule, there's no such thing. All right, so that we can just see that there are no moving. Maybe you can talk about charged particles, or if you want to be specific, maybe you can talk about like ions, electrons, right? Ionic compounds, they conduct electricity in molten or aqueous solution when the ions are free to move, or in the case of metals, it's due to the electrons that are free to move. They are delocalized within the metallic structure. All right, so these two being absent in phosphorus, right, means that it is unable to conduct electricity. Moving on to B, phosphorus P4 reacts with air to produce phosphorus 5 oxide P4O10. Write a chemical equation for this reaction. So we have P4. So the fact that it forms an oxide means that it reacts with oxygen in the air that forms P4O10. All we need to do is to balance it. So we see that O is we have 10 oxygen atoms on the right. Hence, we just need to make the number of oxygen atoms on the left in total 10. So just put a 5 in front of O2. Moving on to, what type of chemical reaction is this? So this is actually just a simple redox reaction, or you may just call it as a combustion reaction. Right? Moving on to C, phosphorus 5 oxide P4O10 is an acidic oxide. It reacts with aqueous sodium hydroxide to form a salt containing the phosphate ion. Water is the only other product. Write a chemical equation for the reaction between phosphorus 5 oxide and aqueous sodium hydroxide. So we have P4O10 and it reacts with sodium hydroxide. The formula is NaOH. And this forms phosphate ion, a salt that contains phosphate ion. So since we're using sodium hydroxide, it means that we will form a sodium salt. Yeah, we should form a sodium salt, and then that allows a phosphate ion. So these are the charges, PO4 3 minus, hence it will be a 3:1 ratio as of sodium has a +1 charge. Right? And then that allows the formation of water as well as the other product. I think that's pretty much it. The next step is just we need to balance the equation. Yep, that's the first mark, which is the chemical formula is correct. And then the second mark is of the balancing part. Now, the easiest way to get started is to just look at the elements that occur only once, which is in this case is sodium. So what I'm seeing here that here is a 1:3. As you can see, it's a 1:1 ratio. So we should adjust that accordingly by, let's just experiment with putting a 3 in front of this. All right. but it's not definite yet. Now I see P has 4 on the left, and on the right there's only one. So we need to put a 4 in front of this, making the sodium just now a 12. Right, seems like it will be more advantageous for us to balance the P first. Okay, so P4, there's 4 on the left, and then I'm making my P's, my phosphorus 4 on the right. And then by doing that, I'm having 12 atoms of sodium on my right now. So let's put a 12 on the left. And then next, just focus on maybe hydrogen. So I'm having 12 on my left. I need to put a 6 on my right. And then let's just focus the last element, which is oxygen. On my left-hand side, altogether, there's 4 and, excuse me, that's 16, and also there's 6. On my right, there's 10 and 12. Yeah, that's balance. That's balance. So it's not an easy equation to balance, but it's balanceable. Okay, so just be careful with the balancing part, and you should be able to get the second mark. Right, the tip is to just focus on the elements that occur only once, so it will be easier for us to balance. Moving on to the next question. Phosphine has the formula pH3. Complete the dot and cross diagram to show the electron arrangement in the molecule of this substance. So show outer shell electrons only. Okay, so let's just identify real quick. Phosphorus is a group 5 element. Hydrogen is a group 1 element. And we know that group 5 elements will need, I would say, 3 more electrons to become balanced, to have a stable electronic configuration. For hydrogen, it will need another electron for that. In other words, you will need 3 pair of electrons for phosphorus, bonding pair of electrons. For hydrogen, you will need 1 bonding pair. Right, that's the overall gist. Okay, so what we need to do is we need phosphorus to, well, contribute first for sharing. So phosphorus, right, group 5 element means that it has 5 electrons. 5 electrons. So let's just draw that first. 5 electrons, and then we mentioned that it needs to contribute 3 of the 5 electrons to share with the hydrogen atoms. Right, as you can see, 1, 2, 3, 4, 5. To get 3 bond pairs, phosphorus has to be contributing 1 for each to hydrogen. For hydrogen, as you can see, it's having 1 electron originally. So if we just contribute that for sharing. Right? If you can't use this method, there's also another method that I think it will work, which is group 5 elements, right? I like to code it as it needs 3 lines to become stable. Right? 3 lines to become stable. And then for hydrogen, it needs 1 line to become stable. So you just do, I would say, like a stick diagram, and then you just stick them together. Then you should be able to get this structure. All right, that's the rule of the game. Hydrogen needs 1 line, and phosphorus needs 3 lines. Okay, that's why the structure looks like that. So that's the answer for D. Right, that will be 2 marks. 1 for the bonding electrons, 3 pairs of bonding electrons. The last mark will be on the non-bonding pair on phosphorus. Let's move on to the next question, which is this molecule has a similar chemical structure to ammonia, NH3. Ammonia acts as a base when it reacts with sulfuric acid. What is meant by the term base? Pretty straightforward. It's a proton acceptor. Moving on to 2, write a chemical equation for the reaction between ammonia and sulfuric acid. So ammonia is a base, NH3, and it reacts with sulfuric acid, which has the formula H2SO4. We will expect to see essentially a salt, right? So ammonia forms an ammonium salt. So NH4, wait, just let me double check. This one is a 2 minus ion, this one plus 1. So you will get 2 sets of ammonium with pairing with 1 sulfate ion. Right, so this is ammonium sulfate. And this reaction actually doesn't produce water. Right, so that's it. Let's just balance this equation. As we can see, there are 2 pairs of ammonium. So you need 2 pairs of ammonia. Right, nitrogen is balanced now, 2:2 ratio. Sulfate is 1:1 ratio, that's fine. Hydrogen, there's 8 on the left, and then there's 8 on the right, that's balanced, right? So that's the answer. As usual, 2 marks for the one for the chemical symbols, the other one is for the correct coefficients for each chemical. Right, moving on to the next question. 4. Methanol is made industrially by reacting carbon monoxide with hydrogen. The gases react at a temperature of 250 degrees Celsius and a pressure of 75 atmospheres. The fourth reaction is exothermic. Suggests the source of hydrogen for this industrial process. So mainly we can get hydrogen just from natural gases. All right, or you can just say hydrocarbons. Then for B, complete the table using the words increases, decreases, or no change. So the first part is on the rate of reaction. The second part is on the equilibrium yield. As we mentioned many times, that these two are different concepts, right? So you should split them, okay, and analyze them individually. So for rate, right, we know that pretty straightforward, regardless of the type of reaction, adding a catalyst increases the rate of reaction. Increasing the temperature does increase the rate of reaction, and decreasing the pressure will definitely decrease the rate of reaction. That's what we know for rate, right? Equilibrium is a little bit more complex, where adding a catalyst does not affect the yield at all, right? But temperature and pressure will be a different story. Increasing temperature favors the endothermic direction. All right, so depending on the forward and the reverse reaction, which direction is endothermic? So there will be the reverse reaction, because as mentioned, the forward reaction is exothermic. The reverse reaction should be endothermic. So it will favor the reverse reaction, making the yield lower. Right? So next, decreasing the pressure. So this will actually favor the reaction direction with more gases. So that will also be the reverse reaction. As you can see, there's 3 on the left and 1 on the right. Okay, so that will mean that this one will favor the reverse reaction, making the yield decrease. Right? Moving on to C, methanol is a member of the homologous series of alcohols. State 2 general characteristics of a homologous series. There's actually a lot, but we can just mention a few. For example, they share similar chemical characteristics due to the presence of the same functional group. Right, these two are linked together. Right, you can also mention many other answers about homologous series. Like for example, they have the same general formula. They differ from one to another by a CH2, and then they also have like showing a trend change in their physical states. Right, along the physical properties essentially vary and show trends along the homologous series. Right, so there's many ways that you can establish this. Meanwhile, moving on to 2, draw the structures of 2 different alcohols, each containing 3 carbon atoms. Show all of the atoms and all of the bonds. Name these 2 alcohols. So when you're talking about an alcohol with 3 carbon atoms, we should expect seeing propanol. So we need to draw the two different alcohols about propanol. So let's draw that propanol. Start with the backbone first, triple C, and followed by the filling of a functional group. And in fact, that makes them different. So we can draw the first one as having the functional group. Alcohols have hydroxyl functional group. We can draw this for the first isomer, we can draw it on the first carbon. For the second isomer, we can just draw it on the second carbon. Right, so you can get two different alcohols in the same time, and then we can just fill in the blanks by using hydrogen. So fill the rest of the space by hydrogen. Just remember that each carbon has 4 lines, as it's a group 4 element, and that allows us to draw the structure. Right. Let me double check the answer real quick. Yep, that's how we draw it. Remember, carbon is a group 4 element, it must have 4 lines. Oxygen is a group 6 element, it must have 2 lines. Hydrogen is a group 1 element, means that it must have 1 line only. So let's say the name individually are propane 1O and propane 2O respectively, where the numerical number represents the location of the functional group. All right, moving on to 3. What term is used to describe compounds with the same molecular formula but different structural formula? There will be structural isomers, which is what we have been drawing. Right, these two are actually structural isomers. Moving on to D, alcohols react with carboxylic acid to produce esters. Name ester S. So the structure has, let me just establish this real quick. So how do we recognize this? We cut via the bond between the carbon-oxygen double bond and also the carbon-oxygen single bond. We cut in between that, and then we are able to recognize that the one with the carbon-oxygen double bond is actually originating from the carboxylic acid. And the one from that has the single bond, what do you call it? 2 single covalent bonds for the oxygen atom, that will actually be originating from alcohols. So with that said, this thing is actually, as you can see, this is a 2 carbon alcohol. This is a 1 carbon carboxylic acid. So the name will be, this one will be ethanol originally and methanoic acid originally. Combining them together to form an ester, there will be ethyl methanoic. The first name is originating from the alcohol. The second name, the last name is, it originates from the carboxylic acid. Moving on to 2, give the name of the carboxylic acid and the alcohol that react together to produce ester S. Sorry, ester X. So we have that answered right. The ethanol and also the methanoic acid. Right, by understanding the structure, where did it come from, we should be able to answer this straight away. Moving on to 3, ester Y is different from ester X, but also has the formula of that thing. Draw the structure of ester Y, show all of the atoms and all of the bonds. Okay, so you can just modulate this slightly. Right, if you are using methanoic acid and ethanol, you can pretty much just use methanol and ethanoic acid. Essentially just transfer this CH to the other side, right? This CH2 to the other side. Let's draw that real quick. So now the carboxylic acid part has 2 carbon atoms. All right, then this is the bridge that links to the alcohol just now. Right, then we just draw this one. We'll have only 1 carbon left as we borrowed the CH2 to the other side. And we just need to fill in the rest with hydrogen. All right, so this one is the ethanoic part, and this part is the metal part. So this one is known as, even if you can't draw, you must be able to name it at least, which is it's called metal ethanoic, right? So that's the answer. Yeah, the 2 marks is just the correct ester linkage, and also the whole molecule is drawn correctly. So that's 2 marks. Moving on to the next question, which is quite long. Copper 2 sulfate crystals are hydrated. These crystals are made by reacting copper 2 carbonate with dilute sulfuric acid. The equation for the overall process is shown. Powdered solid copper 2 carbonate is added to 50 cm³ of 0.05 mole per cubic decimeters sulfuric acid until the copper 2 carbonate is in excess. The excess of copper 2 carbonate is separated from the aqueous copper 2 sulfate. The aqueous copper 2 sulfate is heated until the solution is saturated. The solution is allowed to cool and crystallize, and the crystals are removed and dried. Calculate the maximum mass of the copper 2 sulfate crystals that can form using the following steps. First of all, calculate number of moles of sulfuric acid in 50 cm³ of 0.05 mole per cubic decimeters of sulfuric acid. How can you find number of moles from these two data? So let's just understand what the units are about. First of all, this is the volume, cubic centimeters. This is the volume. This one mole per cubic decimeters. This is actually the concentration. How can we find the number of moles? By simply using the formula N equals to CV, or some books will use MB, right? So number of moles equals to volume times concentration. That's it. Let's just apply the formula real quick. It's, remember to change this to the same unit to cubic decimeters, that it can be done by dividing by 1,000, multiply by 0.05. Use your calculator for this question, and you should be able to get the answer. So there will be 0.0025. Now, determine the number of moles of the hydrated crystals that can be formed. Now, look back to the question. The given data is based on sulfuric acid, and the product that is like asked from the question is this particular product. So based on the equation alone, forget about everything else for now. Just focus on this equation alone. We see that this equation, the coefficient for both materials are a 1-to-1 ratio, right? In moles, okay? In moles, this whole equation is written in moles, where 1 mole of sulfuric acid reacts with 1 mole of that hydrated crystal. So since we're using 0.0025 moles, it will mean that we will form exactly the same amount because it's a 1-to-1 ratio. Right, moving on to the next question. So the relative mass of the hydrated crystal is 250. Calculate the maximum mass of this hydrated crystal that can form. So this is, let's see, this is a relative mass, or should I say, essentially you can use this as your molar mass. So how can we find mass from moles and molar mass? By using the formula mole times multiply by molar mass. So it's pretty straightforward. We just need to take 0.0025 multiply by 250, and we get the answer, which is 0.625. Pretty straightforward. All right. Moving on to the next question. Steps 1 to 5 were done correctly, but the mass of crystals obtained was less than the maximum step. Excuse me, maximum mass. Explain why. Let's see. This whole process is crystallization. And we see that like the theoretical and the the practical version are two different stories. We are having less mass. That is expected. That is expected in almost all experiments, right? We can't possibly be what do you call it? Having 100% yield, right? So there must be a few factors that affect the whole reaction, like any of the steps, right? Maybe we lost some materials that can happen as well, right? So we can maybe can just mention like some crystals are lost in the transfer. Right, because we're transferring so many things at once, like 5 steps of essentially moving things around. So we may actually overlooked and didn't pass everything to the next step. Right? So we can also see that some of it may be decomposed. Right, because essentially it takes time to do all of the steps. Some of it might have broken down in the process. And you can just see that maybe some of the materials didn't form any crystals. Right? There's many possibilities of why the the view is not 100%. Right? The view is, it's almost impossible to get 100%. Right? Moving on to C, state 2 observations that would indicate that the copper 2 carbonate is in excess in step 1. Where we're adding the solid and in excess, so means that some of the solid might just not dissolve in it. Right? So the solid might just not just might, it's definitely will stop dissolving once you reach a certain threshold. Or you can say that, well, this reaction, right, if you see closely, it produces carbon dioxide, which means that you will expect to see efflorescence. So this is, well, you will just see the efflorescence stops right after the copper 2 carbonate is in excess. Moving on to D, when the reaction in step 1 is done using lumps of copper 2 carbonate instead of powder, the rate of reaction decreases. All other conditions are kept the same. Give a reason for this. Explain your answer in terms of particles. Well, this is about rate of reaction using this. So we just need to mention that the lumps have a smaller surface area. And as a result of that, the frequency of collision decreases. And we can just see frequency of effective collision decreases. Right? Which leads to essentially a lower rate of reaction. Right? Keep things simple. All right, these are for the lumps compared to the powder form. Right, moving on to E. Name a different substance other than copper 2 carbonate that could be added to dilute sulfuric acid to produce copper 2 sulfate in step 1. Right, we can't just use copper because copper doesn't react with acid. So we have to use, like, let's say, for example, copper 2 oxide. Right, or we can just use copper 2 hydroxide, which essentially both of these are bases. Bases react with acid. Right, normal copper is just too unreactive to react with metal. For F, name the process used to separate the aqueous copper 2 sulfate from the excess of copper 2 carbonate in step 2. So we are removing solid from aqueous solution. That will be filtration. Quite simple. For G, the solution of aqueous copper 2 sulfate was heated until it was saturated in step 3. Suggest what is meant by the term saturated solution. Okay, saturated will mean that it contains the maximum number of dissolved solute, right, at a specific, or should I say at any given temperature. All right, individually, this will be 1 mark and 1 mark each. All right, moving on to 2. What evidence would show that the solution was saturated in step 3? Essentially, you just use a glass rope and just stir it around and see if you see any solids, all right, on that deposit on the glass rope. So you can just see when crystals form on the glass rope withdrawn from the solution. Right? Why should the aqueous copper 2 sulfate not be heated to dryness in step 3? You see, the point of the whole experiment, right, is to isolate these copper 2 sulfate crystals in hydrated form. If you choose to heat it like way too dry, you would actually lose the water of crystallization. All right, this will actually remove water of crystallization, which is undesirable in the case of isolating, purifying, crystallizing the substance. All right, moving on to the next question. Number 6, the halogens are the elements in group 7 of the periodic table. Predict the physical state and color of acetylene at room temperature and pressure. This is kind of a more of a lower position compared to other halogens, right? Fluorine, chlorine, bromine, iodine, and acetylene. Acetylene is the fifth, the fifth row of halogens. As we progress from one halogen to another, we should expect to see the state, right, becoming more and more, the particles get more and more packed together, which means that we will expect to see solid state, right? Fluorine, chlorine usually is a gas, bromine usually is a liquid, and then for iodine, it's mostly a solid at room temperature and pressure, right? So you expect to see them to become more and more, the particles are more and more packed, so you will expect to see a solid. Whereas for color, we will expect to see the color get darker and darker and darker. So this one should be a black color, black solid, right, for acetylene. Moving on to B, when chlorine reacts with aqueous potassium bromide, a displacement reaction occurs. Describe the color change of the reaction, of the solution. So in the solution, this thing, right, potassium ions and bromide ions, they are colorless in nature, making the solution colorless. But when chlorine comes in, it displaces the bromide out. So bromide comes out as bromine molecules. So this will mean that this solution will turn brown, right, as bromine is brown in color. Moving on to write a chemical equation for this reaction. So we're taking chlorine. Remember, chlorine occurs as a pair at molecular state, and then it reacts with potassium bromide, which is KBr. That allows a new potassium halide to be formed, which is potassium chloride, KCl, and bromine comes out, which is Br2. Let's just balance the equation real quick. Pretty simple. 2 to 2 ratio. So this one should be a 2, this one should be a 2, 2 to 2 ratio. All right. Moving on to the next question. Reactions occur when some aqueous solutions of halogens are added to aqueous solutions of halides. Use the key to complete table to show the results of adding halogens to halides. So the ones with reaction will be the ones that are more reactive than the other halogen. So chlorine is the most reactive out of all. It's able to displace bromide and iodide from the solutions. Bromine is the second place, all right? Second place. So this one will be able to displace iodide, but it is unable to displace chloride. Then iodine is the weakest out of these three, so it is unable to displace any of the, essentially it is unable to displace the other two. Right, moving on to question number 7. Displacement reaction occurs between metal and metal ions. Displacement reactions can be used to determine the order of reactivity of metals such as lead, nickel, and silver. The ionic equation for a displacement reaction is shown, and the ionic half equations for this reaction are shown. The ionic half equations show that electrons are donated by nickel atoms and accepted by lead ions. Identify the reducing agent in the displacement reaction. Give a reaction for your, reason for your answer. A reducing agent undergoes oxidation by itself. So this substance, right, should be nickel, as it donates electron to lead-2 ions. Right. Moving on to the next question. What is the general term given to the type of reaction in which electrons are transferred from one species to another? That will be just redox reaction. Right. We can define redox reaction as part of the transfer of electrons from one species to another. For the next question, the ionic equation for another displacement reaction is shown. Write the two ionic half equations for this reaction. So we're observing lead, neutral lead atoms changing into lead-2 ions. How can that happen? By lead giving out 2 electrons, right? And then the next change that is occurring here is the fact that silver ions turn into silver. So how can that happen? A positive ion can become a neutral atom by getting neutralized by electrons. Right, so this is how you write the ionic half equation. Now, C, use the information in A and B to put 3 metals, lead, nickel, and silver in order of reactivity. So from what I see here, the strongest out of these two will be, the most reactive out of these two will be nickel, as it displaces lead 2 from the solution. So nickel is stronger, or should I say, more reactive than lead. And on the next equation, we see that lead is able to displace silver ions from the solution. So that will mean that the sequence is nickel to lead to silver. All right, next question. Nickel is a transition element. Nickel is stronger than sodium. Describe 2 other differences in the physical properties of nickel and sodium. So since nickel is a transition element, right, we will expect it to have a higher melting point than sodium and also higher density than sodium. All right, moving on to the next question. Predict one difference in the appearance of aqueous solutions of nickel compounds compared to aqueous solutions of sodium compounds. As we know that nickel compounds, right, nickel is a transition element, which means that the solutions of nickel compounds should be colored. Right, transition elements, they are colored, they form colored compounds or colored ions. All right, moving on to the next question. Copper is refined or purified by electrolysis. Nickel can be refined using a similar method. The diagram shows the refining of nickel by electrolysis. Complete the labels in the boxes. So in electrolysis, in terms of like refining or / purification of metals, the anode should be made of the pure nickel. No. Anode should be composed of the impure nickel, my bad. Because the anode, right, essentially it will strip away, it will dissolve. Right? So you want the impurity to dissolve. Okay, my bad for confusing this one. So yeah, so the anode should contain the impure nickel where it can dissolve and get purified. Whereas for the cathode, it's made from the pure nickel. And then for the electrolyte, right, we should just use something that contains nickel, right? We shouldn't introduce new metals into the solution, right? Or else it's very messy. So we need maybe we can use any, like, let's say nickel nitrate or anything similar. So we can see nickel salt, right? Or nickel like nitrate, for example. All right. Let me check something real quick with this one. It's nickel. Yeah, it should have a nickel 2 nitrate, for example. Okay, let me just put an example here. Nickel 2 nitrate. Right, nitrate salts are usually preferable in like electrolysis. Right, and last question, I believe. Yeah. indicate by writing N on the diagram where nickel is produced. So when we strip away the impurities, right, we should expect it to form at the cathode where deposits are made. Right, depositing occurs at the cathode. Right, so okay, we labeled that. So I guess that's all for the paper. Thank you for watching, and I'll see you in the next one. Bye.